In Module 4, we're going to look at layer reference as it relates to layers being created by drawing views. And we'll look at the Autocad help menu to help us along. We'll look at offset and align sections, as well as detail and auxiliary views. So we're going to create 4 different types of drawings, applying the different drawing views techniques. So let's go into Autocad and let's create these new drawing views. Let's step back for a moment and let's take a look at Autocad help, because I do want to call your attention to the drawing view layer reference. And I'm in Autocad 2013 help, and basically here's what it says. When you create a model documentation drawing view, the program draws view geometry on predetermined layers depending on what the geometry represents. I know I just read that to you, but look at the key. As we have been creating our different views, different layers have been created. So whether you're using Autodesk Inventor or Model Space in Autocad, if you look at the entity represented by geometry, then what layer it gets drawn on, you get a good understanding of how Autocad will build a layering structure around drawing views. I'm going to scroll down a little bit so you can see other types of layers that are being created. So when we use Autocad and when we create our views, be very cognizant of the layers that are being created, because in many cases you're going to want to manipulate those layers by turning them on and off and freeze thaw, etc., etc. You get the idea. We can create offset sections in Autocad 2013. So the part that I have has holes that are sort of offset, slots. So this makes a good candidate for an offset section. So on my ANSI B sheet of paper, I've already created the top view for us. And I'm going to go into a offset section. So when I select the view that I want to offset, I can come in to start to track. Again, make sure you have your tracking turned on to track over. I'm going to track there, and then I'm going to go perpendicular to that notch, come up and track off the center of that circle, and then bring my cutting plane line over to the right. I'm going to press enter, and then my line of sight projects downward to create that offset section view. And there it is. And that's what AutoCAD will give us as we create that section view based on the cutting plane line. Now what I can also do is do a projection, and I could project off of that view to create that isometric with sectional view applied. So that's the resultant of placing the cutting plane line in its current location. And of course, you can change that to at any offset direction or distance you want to go from one object to another. But what if I change the cutting plane line's location? I'm going to go in and select grips, and I'm going to move that cutting plane line over to right here. You can see I'm tracking off. So I've totally changed where I want to go with my cutting plane line. Let's see how the views have updated. So just by changing and modifying the placement of that cutting plane line, I've created a different front and isometric sectional views. In AutoCAD 2013, we could also create aligned sections. So on my ANSI A sheet of paper, I'm going to go in and create an aligned section 2 different ways. I've already created the top view for us, but I'm going to go in and draw a polyline right on top of that view, and this polyline is designed to become my cutting plane line for my aligned sectional view. So when I go into section, I'm going to go from object. I'm going to select the part and then select the polyline to represent that cutting plane line. bring down my angle of sight, select a position, and there's my aligned sectional view. Let's create the section view a different way. I'm going to go into Section and select Aligned. In this case, I'm going to come in and pick my points instead of creating that polyline first. And again, the polyline you can create first or use aligned. And the polyline is only used to create specific locations and sometimes make it easier for you to depict where you want that section line to go. So let me bring this down and select the position of where I want my aligned section. And there it is. But wait a second. Is this a true drafting practice? In other words, in drafting terms, we want to make sure that this view is designed by a conventional drafting or conventional drawing practice. So what I did is I went in and I created a layer called Construction. And on that construction layer for my conventional practice, that arm that rotates down, looks like about 30 degrees, needs to be rotated up before it gets dropped down. So if you look at the alignment of the aligned section, this is a good drawing. It follows CAD drafting standard practices. However, I do want to call your attention to some options. So if I select that view and go into Edit View, the projection is based on normal. Watch when I change it to orthogonal what happens. Can you see how the part becomes foreshortened and does not relate back to that conventional drafting practice? So that view is actually drawn wrong based on conventional drafting practices. I'm going to go ahead and select that view again and reset that back to a normal projection, and that's what we're looking for. Now the question is, can I create the isometric view from this normal projection? So if I go into Projected and I'm going to select this view, I'm going to go ahead and select the view. Cannot project a normal section view. So I do call your attention down to the command line. It's saying I can't do it. Let me try it one more time. So if I come in here and select it, I guess I can't, it keeps telling me I can't do that. So it looks like that once we create normal, we cannot project a normal section view. So let's step back. What if we selected the view, edited the view, went back to orthogonal, okay, and then projected the view? Could we do it this way? Well, the answer is yes. You can do an orthogonal view for that isometric, but you cannot do a normal view. So it's a give and take situation. And you're going to have to leave it up to your standards within your company. But those are some examples of how to create an aligned section view. The model that I have has an inclined surface. And that surface is foreshortened in the top view or in the right side view. So what I need to do is to create an auxiliary view off of that angled face. So again, my front view has the angle determined off 30 degrees. Top view is foreshortened. Right side view is foreshortened. And then of course I have the pictorial at isometric view. So I'm going to create an auxiliary view off of the front view. To do that, I'm going to go in and create a full section. Full section, you say, where's the auxiliary view button? Well, there's no auxiliary view button. So I'm going to go in and select that view. And now when it prompts me for the start point, I'm going to need to zoom in here because there's a fillet, a round on that. I need to pull that down, come back over here, project off a little bit, track off a little bit, got it. And there's my cutting plane line on the face of that angled surface. I'm going to project out the object, select the position of where I want it, and press enter. And there's my auxiliary view of that angled surface in true size and in true shape. So let's take a look at the view. What's missing? First of all, in the auxiliary view, we have no hatch pattern. There's no section lining, no cross hatching. And then off of the front view, where's our cutting plane line? That's gone too. Well, I already set that up before I did this demonstration. So I'm going to go into layers. And remember, I just talked about layers, and I do want to call your attention to the layers that have been created in this drawing view model. And notice that MD annotation is frozen. I'm going to go ahead in and thaw that layer. And now I call your attention to how the drawing looks. So what happened was I already predetermined that I was going to freeze those layers when I created the auxiliary view. So if you are going to create a true size and true shape view of an inclined surface, make sure that you put the cutting plane line and the labels on a layer that you can freeze. Just a simple technique to create true size and true shape auxiliary views. Since I created this auxiliary view, can I put dimensions on here? The answer is yes. Could we put dimensions on here to check to see if it's an accurate auxiliary view? So let's do this test. I'm going to go in and put a diameter dimension on one of the circles, which of course represents a hole that's drilled through that inclined surface. I also want to put in an aligned dimension from one corner to the opposite corner, and that distance is 2.5. So let's go into the model and let's use distance across the model to check. When I'm in the model, I'm going to zoom up to check the diameter of one of these holes, but let me actually check the radius. So I'm going to do a DI for distance from the center of the top face of that to the quadrant of the edge of that face circle. And I should get 0.125. That's correct because that's the radius times 2 gives me 0.25. Now let's check across the face. Now as I zoom in here and look at the face, I notice I have some rounds that were created using, of course, the fillet command. So I think I'm going to come down to the front face, which is exactly the same distance across, and just do a DI for my distance from the midpoint to the midpoint, and I should get 2.5. So my auxiliary view did project in true size and in true shape. In AutoCAD 2013, we have the ability to create detailed views. So on my ANSI A layout, I'm going to come in and create base view from AutoCAD. And I'm going to create that front, top, right, side, and isometric views of the chair assembly. I need to scale it. I need a little bit more room on my sheet of paper. So I'm going to scale that parent view. And then if I need to move the parent view, I can move the parent view. And any corresponding child views that are attached will move accordingly. So let's zoom in and let's create a detail. When I go up to the Layout tab, Create View panel, I can select detail for a circular or rectangular detail. For today, I'm just going to show you circular. And as I select that view, I can come in and create a detail around the area that I want to detail, and then position that detail anywhere in my drawing. I can also go in and resize and move the detail anywhere in my drawing to get, that's a little bit better. I sort of like that. I can also make it larger if I want to pull out and make it even larger. So you have the ability to use grips. I really like the ability to use grips to change the way the detail looks. I can also go in and move the label. So I'm going to move this label up a little bit. I like that. And then I'm going to come up to the style of the label. Let's take a look at modifying that. And under the view label, I can change the text height. I like the text height where we have it set. Under detail boundary, if you watch the preview, you can see how I can make changes and modifications to the details as I select. So you have different options. So smooth with connection line. We can also change a connection line color or the borderline color or line type as needed. And then I could come into the identifier and change the arrangement or the text style. And again, you can go in like any other style and make modifications and changes. For today, I'm going to leave everything as is.